Welcome to the new session. So we are going to do a practical walkthrough on the import descriptor and IET table. So go and download this project 02 Calc IET, unzip it, put it in MailDev2 folder, and inside here you will find there's already a WinNT header file. If you open the README file, you can see the location where you can get it from, and also the location for Calc ESE. So let us open WinNT with Notepad++, and then we look for import descriptor by searching for it. Click on search, find, and type in import underscore descriptor or DES, and then it has found it here. And then we will open the location for calculator, which is found in this path. So PEBar, and we can file load PE and go straight to C Windows, System32, and then calc.exe. Click open, and it is loaded. So now we will put our import descriptor side by side with your PEBar. Head over to the optional header here and scroll down, and under this field import directory, right click on this, follow RVA up here. So now in this RVA here, you can see all the structures for this import descriptor. There are quite a few here. So let's see. Click on imports here. The first one is advarp32dir, and it is at offset D1E8. It's 4 bytes here. So this 4 bytes here is for advarp, and it stretches all the way until the next one, which is D240 here. This is the start of the next structure, which refers to kernel 32. 0 D240, and then the next one will be D460, which starts here. D460. This is the third structure. So here you have many structures altogether. You can count the number of structures here. If you count from here, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 import descriptor here altogether. So let's study the first one, advarp. Advarp starts at D1E8. So it starts from here, stretches here, continues until here. The next one is 0D240, which is kernel 32. So kernel 32 structure starts from here. So from here to here is your structure for advarp. So the first 4 bytes refers to your original first chunk. D1E8, as you can see here. And then the next 4 bytes is your dime date stamp, which is all Fs. The next member will be your forwarder chain, which is here, again all Fs. And then the next member will be your name, which is here D1, D4. You must read it in reverse order. So this D1, D4, if you go there now, right click and follow, you should be able to see the name advarp in here. RYPDL. It's a string name for RYPDL. It's a friendly name for this DL. Let's go back. And then the next member will be your first tongue. So your first tongue would be this one. So this is the last member here. So the first tongue is a pointer to the import address table. So import address table is down here. So at the moment you can see the import address table contains 10 entries. That means there are 10 functions in RYP32DLL. If you click kernel 32, it will load kernel 32's import address table containing all the functions that are imported for kernel 32, GD32, user 32, and so on. Okay, let's go back to RYP. So when you click RYP here and you come down to the bottom, you will see RYP has got all these entries. We have 10 imported functions, and over here is your first one, and this is the hint. So every one of these functions has got corresponding numbers. It's just like an ordinal number. And then here, if you click on this and follow, you can see the name here, the hint plus the name. See that? 27E is the hint. It's just like an ordinal number. And then the rest is the string name, regSetValueEx. regSetValueEx. If you went to the second one, follow in RBA, you will see the hint 26E, followed by the string name regQueryValueEx. regQueryValueEx. If you now follow the third one by clicking this, you will come to the hint 23C, followed by the friendly name for this function, which is regCreateKeyW. regCreateKeyW. So this is how the thing works, and this is how we can analyze all these import address table. So one thing important to remember is the original first tongue is a pointer to the start of your DLL. So for example, if we go back here, so your original first tongue is this one here, and then when it first loads, it doesn't have an address for each one of these functions, but it will look up using the hint, and eventually the B-loader will populate your import address table, which is this one, first tongue, with all the addresses for this. So this is how it works, how the import address table is being resolved. Okay, so now we can try to take a look at using a debugger, take a look at your notepad. So for the options, click on Options Preferences, and here click on DLL load and System DLL load, because we want to see how the IIT resolves the name for the functions, the addresses for the functions. And this one, leave it checked for breakpoint as well. Now we open your calculator, go to System32, select Calculator exe, click Open, and then over here we go to Memory Map, and notice that only the NTDLL is loaded. All the other DLLs have not been loaded yet, because we put a breakpoint on DLL load. As you can see at the bottom left, it is paused at this breakpoint and DLL load. So over here we go to Calculator text section, and you scroll down and see the calls. Notice that this call to this function is unknown, because this has not been resolved yet into the import address table. So we can follow this, click on this first, come down here, and then follow in dump this address. The import address table has not been resolved yet. So now we have only the function lookup. So now we'll run it and see what happens. So it loads the first DL, kernel 32, and it still haven't resolved the IAT table yet. Load the second DL, kernel base DL is now loaded. Run. Now it loads the next DL, SHA-32 DL. Each time you click run, it loads a DL. So you may need to click it a few times until all the DLs are loaded. Just keep on clicking and you can see all of what are the DLs being loaded. Keep on clicking. Okay, now when you see all this red, that means there are changes being made to this region of memory. That means now the IAT table has been fully resolved. That's why it turns all red. And if you go back to this location in text, sorry, it should be here. Go to the text here, and now you can see your function name has been resolved because the IAT table has been resolved. So if you click on this now and come down to here and follow it in dump, the same address, you will find this import address table with all the relative virtual address for the functions. So we can follow this. Right click and follow keyword in this assembler. Why keyword? Because in 64-bit programs, each address is 8 bytes long. That's why it's keyword. So we follow this keyword in this assembler and we can see get module handle. And you can see this is not a direct reference to an address. It is actually a jump table. That's why you have JMP here. That means whenever you are resolving this function, you will actually go to a jump table to jump to the actual location for the get module handle W. There are some functions which are direct to the function without a jump table. Let's try this one. Okay, this is also a jump table. There will be some where you see there are no jumps but directly references the function itself. So this is the walkthrough on the function lookup table and import address table. Thank you for watching.